Hi guys, what's happening? So, let's have a look at what happened this week. What you're looking at is a test circuit that I created on a breadboard. And this is because the trigger coil wouldn't operate properly. So I sort of made a circuit and it included at least 4 of these optocouplers, as you can see here. And these optocouplers are known to have a beta of 1000, so they'll make a 1000-volt amplification, and that times 4. This is what finally made the, well, you can see an LED here, the LED go blinking completely on and completely off. And I had to do something else for it, so I'll draw a circuit for you so you can see what I did. So I basically started with an LED and sort of needed a transistor, right, to switch it on and off and have a battery, which is, well, right now at about 8 volts. And this would power the circuit. So then you'd say, okay, in order to trigger it, oh yeah, basically instead of a transistor, I used a optocoupler. So this part would be separated right here. Anyhow, it doesn't really matter. Anyhow, you just put a trigger coil there, and at some point it's going to, you know, trigger the base of the, yeah, well, optocoupler, and then the circuit would trigger on. But this was way too weak, so it would never actually come across the threshold of the base. So I decided to basically make a sort of voltage offset by using a voltage divider. I could produce 0.2 or so volts. So like this is the positive of the battery right here. And here's the negative of the battery attached, right? Imagine that. And then you would have 0.2 volts across this capacitor, just too little to actually trigger this transistor right here. And then with a capacitor here, it would take only AC waves from the coil, so that every time the coil moves in this direction, basically positive going here, it would top up onto the 0.2 volts and then open the transistor, or in this case the optocoupler. And when going back, yeah, well, sort of like depleting the voltage here and so closing the optocoupler. So I tried this and it sort of worked, but it was really like a faint, little, too little, way too little. So I added many more optocouplers and that will look like this. So eventually it will look like something like this. I drew it with 3 optocouplers, but in the circuit there's actually 4 of them. So what's happening here actually is, well, yeah, the 0.2 volts offset, right? And then the coil sort of generating a tiny amount of voltage just to generate enough to, trigger the LED in the optocoupler to ground here. Maybe there was also a resistor here, I'm not sure. Just to protect the base of the optocoupler. But then again, there isn't a lot running there. So then, positive from here taken going through this optocoupler or transistor side of the optocoupler, a current limiting resistor here triggering the next optocoupler, taking another positive here going to this optocoupler, current limiting resistor triggering the LED here inside the optocoupler, and then the final circuit, which is the LED lighting on and off. Yeah, well, I thought, okay, if we need this much amplification, 4 of these, and then finally the LED sort of starts to light up, then probably we should be working on this area here because it doesn't generate that much. But so I also tried to, take out this LED, and instead of that, use a transistor to actually drive the coil. And so the coil was driven, and it seemed that there was also too little magnetic interaction to actually propel the rotor forward. So in the end we still had nothing. And because this pursuit of changing the circuit led to basically nothing, I decided to take apart the whole thing again. As you can see, I numbered it so that it would be easy to find it back. And for example, not placing it in the wrong order so that I have to put more effort into filing or drilling again. So that was a good idea, because now stuff fits again. And if you have been watching, you might notice that there are more holes in there right now. Like these. There are more holes. I drilled more holes. So basically I printed another of these and sorta put it like, not like it was supposed to be, just a little offset, so that I could use these lines to make the other holes. And I sort of eyeballed it so it's not perfectly centered in between the previously drilled holes, but it should be good enough, and as you can see it is good enough. So what I tried first is to drill M6 or 6mm holes, because these M3 nuts actually fit in there. And so I did that with a drill press all over the place, make 6mm holes, and then with the normal drill sort of eyeballing where it should go, and then drill a 3mm hole in the side. So I would end up with a hole that would fit this bolt and this nut. But as I did it by eyeballing, and sort of some of them didn't end up exactly center. So I had to make these holes here, which were 6mm into 6.5. I have this drill, so that would, make this work. As you can see, it did. And so after that I also took the PVC sort of, what do you call it? I don't know, ring, whatever, and made it to size. So this is a 1 centimeter, and I also drilled the holes in there. So how did I do that? Well, I sort of went with a marker like in between here and then threw it in there. And then later I drilled these holes, and I figured out sometimes I was a little bit left or right off, so this isn't the best way. If I had to do it again, I would basically sort of wrap this paper around it and then push in these holes, and then so I could lay it flat on the PVC plastic and drill the holes from there so that they would exactly match up. As you can see, not only did I drill M3 holes in there, I also used a 10mm drill bit to sort of make them sunk, so that the countersunk bolts sort of like fit. So as you can see, I'm scattered at the moment, and hopefully this evening we have it so that it all fits together, because then we can try another spin test. Oh right, I almost forgot to tell you. So I believe we started with 8 or so magnets, per bar, iron bar. So now we're going to use 7 magnets, so it will actually be closer, to the coil, so that hopefully we get some more trigger signal. And previously I had 3 of these were N35 magnets, and then 2 of these would be I believe it was N52, or the stronger type, And then another 3 of these would be the N35. So now it's different. It's the N35, 3 of them, and then the stronger one here. You can see probably that's a different one. And I just know that it is. And then 3 more of these N35. So we have 7 magnets, which means that the whole contraption is going to be, you know, flatter. And in order to make it fit, I actually had to sort of sand a little bit of this as well. So sand it off. Oh yeah, I also sort of got glue and glued up these things, so the pieces aren't loose anymore. If you press it, they don't move, basically. So those are a lot stronger. The ring is around, and yeah, we're going to get closer to the coil with the magnets, so hopefully more trigger action. And so what now has to be done is to make this fit. So I have to sort of file a little bit here, and so it'll fit together. And yeah, well, I guess you could say it's the same as last time. I'm going to do my best to try and get it together, and hopefully we can see it run at some point. So, but for now, thanks for watching, and hopefully we'll see something running together now. So here we are back again with the motor on the bench, and as you can see, I sort of managed to get it like mechanically. Wait, let's focus here. So it's tighter now, and I just wanted to show you the LED on the breadboard. Let's take out this transistor. So at first it's off, and when I spin it up, wait, this might take a while. Right, there you go. So it's spinning, and the trigger coil is amplified many times. So now we put in the transistor. So I just put the transistor on top of that because the voltage drop is much lower, so it will take the voltage. As you can see, the current is going in. Yeah, but it's still slowing down. So I guess we still have to look further. Maybe it's like because we're using the twisted wire, which was 21 meters. I don't think that's enough. Maybe we can put those 2 coils in series and then try and see what happens. So this will be for another day. Anyhow, thanks for watching. See you next time.